Section 4.7, completing the square. So if you have a perfect square trinomial, you can find the roots or the zeros or solve it by finding the square roots. So let's take a look at what this means. So if I have this trinomial x squared plus 20x plus 100, I can factor this as x plus 10 times x plus 10. Since my factors are the same, that means it's a perfect square. I could write this as x plus 10 quantity squared, and that equals 81. And now, like we've done in the past two sections, if I take the square root of both sides, then I'm going to get x plus 10 equals 9, and x plus 10 equals negative 9. So then by solving this, I can see that my two distinct solutions are going to be x equals negative 1 or x equals negative 19. So if a trinomial is not a perfect square, we're going to learn how to complete the square to make it a perfect square trinomial. But what is a perfect square trinomial? So let's take a look at these next 6 examples and see which of the following are perfect square trinomials and why. So if you noticed before, we need to be able to factor it as a quantity squared. So this first example, I could factor as x plus 4 times x plus 4, which is x plus 4 quantity squared. Now why does this mean that it's a perfect square trinomial? Well, if I had a square and one side had dimensions x plus 4 and the other side had x plus 4, then it would in fact make a square because both sides, all 4 sides, would be the same length. If we look at the second example, it will factor as x plus 2 and x plus 3, but that's not a perfect square trinomial because if I were to again make a box out of it, one side would be x plus 3, the other side would be x plus 2, so it's not a square. It would factor, so it would make a rectangle, but it's not a perfect square. And a difference in your note packet, I believe it's x squared minus 5x, and I just wanted to change this to the plus 5x to display what I meant by not being a square. And so yours in your note packet, if you want to change it to a plus, or if you were to factor it, it would be x minus 2 and x minus 3 for the one in your note packet. If we look at the next one, x squared minus 14x plus 49. Well, again, I can factor this as x minus 7 and x minus 7, which is x minus 7 quantity squared. So again, this is a perfect square trinomial. And the next one, r squared plus 2r plus 4, this one doesn't even factor. So it's not a perfect square. And if you look at these last two, neither of them factor as well, so they are not perfect squares trinomials. But don't be mistaken into thinking that just because it factors, it's a perfect square. Because if you remember that second example that we did, it factored, but it wasn't a perfect square trinomial. Now let's try to find the value of c to make a perfect square trinomial and then factor it. So in other words, what value is going to go in here to make it a perfect square trinomial? Well, we're going to have x times x will give us our x squared, but then we need to find what's going to go in there so that we multiply these two middle terms. To get the middle term, we're going to end up with 6x. Well, if it's got to be the same, it's going to be 3 and 3. 3x and 3x will give us 6x. And then for my last term, what will my c be? Well, I get that by multiplying the 3 times 3 together, and that would give me 9. And so then this is going to factor as x plus 3 quantity squared. If I look at the next one, again I'm going to start out with the x times the x to give me my x squared. And I need to figure out what's going to be added to those in the parentheses so that when I multiply to get my middle term, I get negative 26x. Well, again, if it's got to be the same, it's going to have to be negative 13 and negative 13. And then, of course, to figure out what my c value is, that's when I multiply those two terms together, and I get 169. So again, this trinomial will then factor as x minus 13 quantity squared. Let's look at a couple others. So again, what's going to add together to give me 2x that's the same? Well, 1 plus 1 is 2. And so again, when I multiply those together, 1 times 1 is 1. So my perfect square trinomial would be x squared plus 2x plus 1. and this factors as x plus 1 quantity squared. I would like you to try to go ahead and, actually I'll walk through this next one with you. This next one is a little bit trickier. Again, I need two things to add together to give me 3. Well, 1.5. But let's write this instead as 3 halves. 3 halves is the same as 1.5. And the reason I'm going to do this is because then to get my c value, remember when you multiply fractions, you multiply the numerator times the numerator and the denominator times the denominator, and we get 9/4. And that's a little bit easier to do in your head without a calculator than multiplying 1.5 times 1.5. Which if you really want to, you could write that as 2.25. And again, it's going to factor as x plus 3 halves quantity squared. I'd like you to pause the video now and go ahead and do the last two to see if you get the c value and the factors correct. And I will go through these anyway without any speaking. Keeping in mind my c has to be what's in the middle squared, and so I get x plus 5 halves squared. So now how are we going to use this? We're going to solve the following equations by completing the square. So if you notice, we don't have a perfect square trinomial with this. But we only need the x squared and the minus 10x to complete the square. So let's move the 1 to the other side. And let's keep this space here because we're going to have to complete the square, so we're going to have to put some value in there. And so again, half of negative 10 is negative 5. We square that and we get 25. But now remember, we're dealing with an equation now, so we have to keep our equation balanced. Since we added 25 to the left, we must add 25 to the right. So now we're going to factor. The left-hand side is x minus 5 quantity squared, and that equals 24. Taking the square root of both sides, squaring and square rooting undo each other, so we're left with just x minus 5 on the left, and we get plus or minus the square root of 24. Keeping in mind we need to simplify the square root, and 24 simplifies to 4 times 6. And again, we're picking 4 times 6 because 4 is a perfect square. Obviously 24 is also 8 times 3 or 12 times 2, but neither of those are perfect squares. And so then we get x minus 5 equals plus or minus 2 square root of 6. Bringing the 5 over, we get x equals 5 plus or minus 2 square root of 6. And now the square root of 6 is somewhat treated when we're adding like terms, somewhat treated like a variable. I can't add the 5 and the 2 square root of 6 because the 2 square root of 6 has that square root of 6. If we were to put this in your calculator, and I'm going to want two answers, I want your simplified radical answer, and I also want the decimal answer. So to get the top decimal answer, I would take 5 plus the 2 square root of 6. That would give me 9.899. And to get this one, I take 5 minus 2 square root of 6, and I get 0.101. And I would like you to round to 3 decimal places. Let's take a look at the next example. If you look back up above on your note packet, every time we complete the square, it's a 1x squared. So in order to complete the square, it has to be a 1x squared. So the first thing we need to do is divide by that leading coefficient of 3. Make sure that you're dividing both sides, everything in the equation, by 3. And when you do that, we get x squared minus 12x plus 50. Again, we don't need that 50 to complete the square. We only need the squared term and the x term to complete the square, so we're going to move 50 over to the other side by subtracting it. Half of negative 12 is negative 6. Squared is 36. And so then we need to make sure that we add 36 to the other side of the equation as well. The left side factors as x minus 6 quantity squared. And then we get negative 14 on the right. Taking the square root of both sides, we get x minus 6 equals plus or minus the square root of negative 14. Keeping in mind that the negative we can bring out as an I. 14 doesn't have any perfect squares that divide evenly into it. So again, my final answer with radical is 6 plus or minus I squared of 14. Putting this into the calculator, again, we can't combine the I squared of 14 with the 6 even after we put a decimal, or even after we get a decimal answer, because we still have that I. So we're going to have 6 plus 3.742I and 6 minus 3.742I. And so again, we still have two distinct solutions, whether it's in decimal or radical form. Find the area of the triangle, or we have the area of the triangle, is 144 square units. Let's find x. So a triangle, the area of a triangle, we're going to use the formula 1/2 base times height. And so 1/2, when we know the height is 2x, and the base is x plus 10, and the only reason I did the height first and then the base was because I noticed that 1/2 times 2 is 1, so those cancel. I'm going to plug 144 in for my area, and so now I have 144 equals x times x plus 10. When I distribute the x, and now if you notice, if you were to bring that over, you may be able to factor it, but let's go ahead and complete the square. So half of 10 is 5, so I need to add 25. 5 squared is 25, but make sure we keep our equation balanced, so we're adding 25 to the other side. So then on the left I get 169, and on the right I can factor that as x plus 5 quantity squared. Taking the square root of both sides, I get 13 equals x plus 5, and negative 13 equals x plus 5. Solving both of these for x, I get x equals 8, and x equals negative 18. And we're dealing with the side of a triangle and the height of a triangle. When I put negative 18 in there, I'm going to get a negative height or a negative base. So obviously I can't use the 18, and so x has to be equal to 8. Now we're going to write the quadratic in vertex form and identify the vertex. You need to make sure that you remember how to do this. We're going to be doing this in this chapter, and this is going to come back, and you're going to have to do this again in chapter 9. So make sure you understand how to do this. So keeping in mind that vertex form is y equals a times x minus h squared plus k. So again, we don't need that 95, so to make things simple, in this example, I'm just going to move that 95 over to the other side. We need the x squared and the 18x to complete the square. Half of 18 is 9. We square that and we get 81. Again, to keep the equation balanced, I need to add 81 to the other side. So then on the left, I'm going to get y minus 14, and then I'm going to factor the right to x plus 9 quantity squared. We're trying to get it into vertex form, so I need to bring that 14 over, and I get y equals x plus 9 quantity squared plus 14. And my vertex is negative 9, 14. But now let's just double check this. If we would have kept it in standard form and found the vertex, standard form we find the vertex by opposite b over 2a. So opposite of 18 over 2 times 1, I would have gotten negative 9, which is what I did get for my vertex. And then plugging that back in for the x to find y, I do in fact get y equals 14. So no matter how I find my vertex, by putting it in vertex form or finding the vertex from standard form, you should get the same vertex. It is the same parabola. And now, the height, y, in feet of a ball that was thrown up in the air from the roof of a building after t seconds is given by the function y equals negative 16t squared plus 64t plus 50. Find the maximum height. So what does the graph look like? Well, it's a negative a, so it's going to open down, so our maximum height is going to be our vertex. And so how can we find that? Well, if we do opposite b over 2a, we find that our vertex is, our x-coordinate is 2, and when we plug that back in, we find that our y-coordinate is 114. Now let's put this in vertex form by completing the square. So again, I need to take that negative 16 out of the picture. I need just the t squared and the minus 4t, because if I factor negative 16 out, Negative 16 times negative 4 would give me that positive 64. And again, the 50 I don't need, so it's outside of the parentheses. Half of negative 4 is negative 2. When I square this, I get plus 4. And I need to add 64. Now, why do I need to add 64 to keep the equation balanced? Well, if you notice, the 4 was put inside the parentheses. The parentheses are being multiplied by negative 16. So what I actually added here was negative 16 times 4 is negative 64. On the same side of the equation, to keep it balanced, I need to do the opposite. So I've subtracted 64. I need to counterbalance that by adding 64. So now factoring, I get negative 16. What's in the parentheses factors as t minus 2 quantities squared. And then 50 plus 64 is 114. And again, my vertex is 2, 114, which matches the vertex that I found before. So what does this mean? It means that after 2 seconds, or 2 seconds after the ball was thrown, it reached the maximum height of 114 feet. This is very important that you can relate the answer back to the question and understand what any ordered pair means. This is a very difficult problem to do, so please make sure you come to class with any questions about it, or if there's another problem in your homework that's similar to it. Otherwise, please remember to go back and do the notes check, and we'll see you tomorrow in class.